In this video, I'm going to go through 2.6 part 2, our second homework here, just these 4 problems that I gave you to try out. And basically it's just using these notes that I sent out the other day on rational functions. I'm just going to go through each of these problems. Starting with number 1, we're looking for the domain, any holes, vertical and horizontal asymptotes. So we always start these by factoring both the top and the bottom. When we factor, the top factors to x minus 2 times x plus 1, and the bottom factors to x plus 3, x minus 2. All right, so on the bottom, we have x plus 3 and we have x minus 2. So both of those are going to give us spots where we have values that aren't in our domain. So x plus 3, if I set that equal to 0 as I did here, if we solve that, x equals negative 3, that's better, cannot be in our domain. So our domain, x cannot equal negative 3, and then x equals 2 cannot be in our domain either. As we can see here, the x minus 2's cancel out with the top and the bottom. Therefore, that is going to be a hole. This x equals negative 3 does not cancel out, so that is going to be our vertical asymptote. Then thinking about our horizontal asymptotes, we look over at our rules. Okay, for this one, n equals m. Okay, the degree on the top and the bottom are the same. Therefore, we have this horizontal asymptote at y equals a over b. If we look at this here, the degrees are the same. A is 1, b is 1, so we have a horizontal asymptote at y equals 1. Now for number 2, this one, when we factor, okay, we can see that each of these has an x in it, so we factor out an x, and then we're left with x minus 1. On the bottom, it factors to x minus 3 times x minus 1. We can see here that our x minus 1's cancel out. These two factors on the bottom give us x equals 3 and x equals 1. Both of those cannot be values in our domain. Okay. And then x equals 3 is a vertical asymptote. X equals 1 is going to be our hole because it cancels out. Same thing for this one. Our degrees are the same on the top and bottom. The numbers out in front are both 1, so y equals 1 is our horizontal asymptote. Then for number 3 here, okay, same thing, factoring this. On the bottom, we can factor an x out of each term, and then we can factor it to x plus 2 times x minus 1. This first x gives us x equals 0 as something on the bottom, okay? That part is not a part of our domain, okay? X cannot equal 0. From this x plus 2, x equals negative 2 cannot be in our domain, and then x minus 1 gives us x equals 1 is not in our domain. Wherever we can cancel this out is going to be a hole in our graph. We're going to have a hole when x is negative 2. These two values we can't cancel out, so both of them are vertical asymptotes. Then looking at our rules for horizontal asymptotes, this one, n is less than m. The degree of the top is less than the degree of the bottom. Therefore, we are going to have a horizontal asymptote at y equals 0, as you can see I wrote here. Then moving on to the last problem here, we can factor an x out of both terms on the top, and we get x minus 1. On the bottom, we can factor out an x. When we factor out an x, we're left with x squared minus 1. Okay. We can factor that by using difference of squares, x plus 1, x minus 1. And from those, we get these 3 zeros here on the bottom, which are not going to be a part of our domain. The x cancels out with the x, making this a hole. And x minus 1 cancels out with x minus 1, which makes this x equals 1 also a hole. X plus 1 we cannot cancel out, therefore negative 1 is going to be our vertical asymptote. Right. For the same reasoning as the last one, the degree of the top is less than the degree of the bottom, so we have a horizontal asymptote at y equals 0. Okay. We're going to continue working on this. Our next section is going to be graphing these examples. We're going to continue to do this process, finding our domain, holes, vertical and horizontal asymptotes.